Papenburg, northern Germany, construction on the new P&O superliner Aurora has hardly begun when the engines have to be installed. They're huge and will generate 79,860 horsepower, more than that generated by 165 Ferraris or 1,331 Ford Escorts. But you can't drop an engine into a completed ship as you could the engine of a car, so they're fitted early and the ship's built round them.
The engine is in the lower part of the vessel, and that means we have to get them very early, much earlier than the ship will be finished. Therefore, we have to plan that in the very beginning, what kind of engines we have to bring in. It's no problem from the weight side because our lifting capacity will be about 600 tons, so the weight of the engine is much less. Therefore, we have no problem at all. But you have to have a very exact planning for that you get them in right in time, and then they are standing there for a year in the ship till they can be started. So also that is different to maybe other ships.
Engineers in particular are acutely aware of the potential problems caused by vibration once the engines are up and running.
The engines themselves are actually fitted on resilient mounts, so they're actually on large pieces of rubber, but they are connected by a highly flexible coupling to the generator, so that and everything else that connects the engine is flexible, whether it be a cooling water pipe or a fuel oil pipe. So with that reason, everything is done possibly to any vibration that comes from the engine is minimised. These are a V14 format, which are more compact, more space saving, and produce a lot more power in the space used. And each one of those drives its own separate generator, which is connected to the electrical distribution system, and as I say, we split that as required for propulsion or hotel load.
The Meyer-Werft yard is 45 kilometres from the sea up the River Ems, and as the engines and generators aren't manufactured at the yard, they have to be brought up the river by barges and then taken off by crane. The Aurora has been designed as a diesel-electric ship rather than diesel-mechanical, as was the case with her sister ship, Oriana. The diesel-mechanical system means the engines directly drive the propellers through a gearbox. On Aurora, the engines will be used to generate electricity, which is then used not just for the propellers, but also as power for things such as lighting and air conditioning. They'll generate 58,800 kilowatts of power, enough to supply the city of Oxford and its 115,000 inhabitants. The technical aspects of a huge ship have a direct effect on the designers.
We've got an opening here and we've put all our walls where we want them to be, and now we've got to put fire doors.
Okay.
And what it's got to do is to protect the cathedral door above.
In London, Alison Clixby is wrestling with the question of how to design around the large fire doors required throughout the ship.
For the entrance,
Café Bordeaux, Champions and Monte Carlo Casino. There you've got lots of different functions in a small space, and you need to create this atrium feel, the cutout between the decks. And for us, the size of the hole means that you have to have certain fire doors to separate the decks. So you're trying to create two different fire zones between what is essentially one space. So you're having to cut it in half, but trying not to do that visually.
It's a difficult task, but the designers have a new device to help them overcome some of their problems, a virtual reality video that shows the interior of the ship before it's even been built. It's the first time that P&O's employed this kind of technology for this purpose. It was created by a company based in the West End of London called Three Blind Mice. Although experienced in film and television advertising, they'd never before gone for anything like this or anything this big.
In order to gain their confidence, because this was a very new thing, not just for P&O but for everyone else who's using this sort of technology, we did test animations for them. So we took a room that was Anderson's room from Oriana and actually did a test animation for them so that they could actually be confident that what we were actually suggesting to them would work in the end. We were given a full package from each of the architects. We were then given the sample boards of all the textures and materials that we used within the rooms. Then we were given all the examples of the furniture, that they might be photographs or plan drawings, etc. And it was given to us as a whole package, so that from the start we were working with a completely designed room, which sort of helped a lot, really.
This is how the plans are supplied to us when we first get them. They're just completely flat, as it would be, because they're only two-dimensional. And based on that information, we go through and model. Here's one of the children's areas here.
The picture is quite literally built up layer by layer. And although originally conceived as a marketing tool, these graphics were to have a profound effect on the way the designers worked.
To watch these people build the inside of the ship in their computers, because we could then see these interiors in ways which we had never previously been able to, and they were available nearly 12 months before the delivery of the ship. It helped us in a number of ways. It helped us to conceive and see the rooms in 3 dimensions, to make final amendments to the architecture and the interior design. It allowed us to produce a very exciting promotional video where we could show our customers precisely what the inside of the ship looked like, well before they could ever see it in actuality. We also used those images in our inaugural brochure for the Aurora, and again that added to the excitement and very importantly gave the customers far more hard information about precisely what they were going to they could expect on the ship.
For the designers, it meant they got advance warning of potential problems.
Quite a difficult problem was getting the seating into Carmen's, because the requirement was actually for 500 seats and the room was just not big enough to house that many people. We had to include a bar, which is different from Oriana, to attract passengers for pre- and post-cabaret drinks. And we also had to maintain a 100-metre square dance floor for ballroom dancing, and that was a really specific requirement that was maintained.
Away from the pressing problems of the showroom in the heart of southern England, the problem of what was going to adorn it was being worked on by Australian sculptor Les Johnson. This being a truly multicultural operation, he'd been given a Latin American theme to tackle.
The basic idea comes from P&O. They have asked for a Latin American dance theme throughout, and each of the individual dancers are inspired by one of the Latin American passionate dancers. And these sculptures will be going inside the nightclub area into niches in the wall. There will be 6 niches and 6 individual dancing figures going inside the wall, and 2 life-size figures will be going outside in the foyer in the entrance, and they are of a dancing couple inspired by the tango. In this case I worked in clay. I personally start to work from the bone structure out to the surface. Because I studied anatomy, I find it easier to work with the bones, get the bone structure right. Once you get all the bone lengths right, you've got the proportions right, then you add the muscular surface to that, and I do the figures nude to start with and add the clothes over the top of that so that all the anatomy is right and the clothes are touching and stretching in the right places. Once the clay model has been approved by P&O, then it's handed over to Bronze Art Foundry. The whole process is going to take approximately 12 months. This is from the time when I did the original drawings through to the time when the foundry completes it and it's shipped over to to be installed in Germany.
Meanwhile, back in Papenburg, Aurora is starting to take on the shape of a ship. Shower and toilet units stand on deck, ready to be fitted. Only now can the sheer size of the ship be grasped. Three Statues of Liberty from base to tip of torch could lie end to end alongside the 270-metre-long ship. Although Aurora is slightly larger than sister ship Oriana, 76,000 gross tons as opposed to Oriana's 69,000, she's taking less time to build, 15 months versus Oriana's 24 months. At the peak, the Meyer-Werft yard will have up to 3,500 people working on the ship. That's in addition to the permanent P&O technical team that's been on site since construction began. One of the major jobs on a ship is the manufacturing of the galleys. They'll be worked hard, having to cater for 2,724 people, made up of some 1,800 passengers and 830 crew.
The galley and catering equipment on board a ship, it has to be a lot more robust than obviously the equipment that you'll find in a hotel. In addition to that, it has to be designed to allow for various safety standards. Obviously a ship moves and a hotel doesn't, so we have to allow that in the design of various equipment. In addition to that, there's various regulatory bodies around the world who have strict regulations, and the equipment has to comply with that as well.
The contract to make the stainless steel equipment throughout the ship has gone to a company based in Charnków in western Poland. Finnish-owned Sea King specializes in the heavy-duty steel needed for a ship's equipment. International health regulations are tough, particularly for ships visiting the United States. But it wasn't just skill and expertise that led P&O to Poland. Money plays a part too.
I think that the main reason was that in Poland was the good opportunity to find quite well-educated workers, but our working cost is still on very low level compared to Western country. So the owner decided to build their own factory here in Charnków, because in Charnków, in previous and time being, there are few companies which has experience to produce goods made by stainless steel, because to produce goods by stainless steel you need a special technology, special knowledge and special experience.
Whilst work continues, P&O people come out to check out a cold food display that's never been used on one of their ships before. The system uses cold air that's wafted over the trays to keep the food at a low temperature. It's vital that the temperature is the same across the whole tray. It'll be checked by public health and safety officers when the ship visits America, so it's vital to get it right.
We're here to see the first iteration of a piece of equipment that we're going to use in our buffet area. It's a cold display unit and actually chills air using cold air, as opposed to the traditional bunker well, which is refrigerated from underneath. So most particularly, we're looking to make sure that the equipment has been changed to embodying the requests we made previously.
Okay, 2.4.
And very importantly, that the food temperatures are maintained within the legal requirements that we have to work.
The corner here is now 5.1 degrees centigrade. And the observation that I would make is that the holes finished here.
Overall, there have been some very good temperatures maintained. We do have concerns in a couple of the areas at the moment. There appears to be one dead corner where the cold air isn't flowing round sufficiently to keep the food temperature cool, because this equipment is not designed to chill food. It's designed to maintain food at the temperature in which we put it in, and we monitor those conditions very carefully.
Just above 4 degrees, isn't it? That's about...
Well, I had 3.9 on one reading, the last one was 4.3. Can we just do that one again?
At the end of the day, all of our food has to be within temperature, not just part of it, and it's critical that we observe those standards.
P&O like what they see, and the first of 35 lorries sets off to drive the 350 kilometers to the German yard. In Papenburg itself, the time has come to partially flood the dock in preparation for the ship being moved down the construction hall. And today, it's the job of a diver to go under the hull to check, quite literally, that there aren't any leaks. Before it was flooded, workmen walked under the ship, making sure that all the plugs in the hull were in place. And whilst he's down there, more workmen check the hull from inside the ship.
Ob du schon irgendwelche anderen Sachen gefühlt hast, Flaschen oder andere Hölzer, Kanthölzer.
Ich habe hier nichts anderes gefühlt. Das Einzige, was man vorstellt, sind solche komischen Haken, wo ich mit Schlauch drin hängen bleibe. Und sonst ist oben alles frei. Das Einzige, was anzogen hängt, ist eine Plane, eine Folie so ein bisschen.
Aber die Folie ist nicht schlimm.
Nee, aber
Klebt unterm Schiffsboden, dass die Holzbohle nicht abreißt, dann reißt nur die Folie ab.
Whilst the diver is down, the dock is only filled to the point just below that which would make the ship lift off the bottom. Only when he gives the okay is more water flooded in and the ship floats for the very first time. A temporary handle is then welded onto the ship, which will be used to help guide it further down the dock. Then, for the first time, the ship moves, guided by trolleys on rails by the dockside. But even now, not all the hull is complete. The bow of the ship is still missing. The ship's built with its stern facing the covered yard's exit and open water, so that only a short section will have to poke out into the elements when the funnel is fitted. Tugs aren't used to move the ship at this point. They're too imprecise, so a system of cables and winches which can move the ship backwards and forwards is employed. At this stage, as it moves centimetre by centimetre, it's hard to imagine that the rust-red hull will become a gleaming white liner capable of cruising the world's oceans at 24 knots an hour. The ship is built in prefabricated blocks, each of which is numbered. The blocks are then welded together. There are 62 blocks in total. At last, block number 59, the bow, is lowered into position. Apart from the 939 cabins, 376 of which will have private outside balconies, there are more than 20 public areas. For some holidaymakers, none of those areas are more important than the swimming pools. And again, virtual reality videos have been used to help the designers and builders in one of the most innovative features of the new ship, the crystal pool with its groundbreaking sky dome.
We have equipped here Aurora with a sky dome. This is the biggest sky dome we have ever built here on our yacht, with dimensions of 20 by 20 meter. It's constructed in 4 sections, and together with the architect and with the designer, we have looked into the possibility to incorporate the whole structure into the silhouette of the ship. So everything is so curved as the areas which are connected to the sky dome.
The dome itself was built in Italy, in Mestre near Venice. It's the 15th sky dome the company have made, but the first for a P&O ship. The dome is constructed in 3 panels, which telescope inside each other, rather like a Russian doll. It's planned that when installed, they'll be able to do this in under 5 minutes. And although the rest of the ship is made of steel for strength, the sky dome sitting on top of the ship has to be light and is made of aluminium. Even then, the designers and the manufacturers were also asked by P&O to use as little metal as possible.
The other demand which we had from the architect and from the owner was to make the structure as light as possible and to produce as big as possible glass areas on top. And so the whole frame concept is constructed as a framework, not longer as closed sections. It's really to bring most as possible light into the pool area underneath.
Back in Germany, deep in the bowels of the ship, the propeller shafts are being fitted. It's a delicate job, even though at times it doesn't actually look like one. In Aurora, the propellers will be what's known as fixed pitch. In other words, the blades themselves can't swivel.
In a fixed pitch propeller, the blades are at a fixed angle, and to vary the thrust you vary the speed, and if you want the thrust in the reverse direction you have to reverse the direction of the propeller, and that's very easily done with electric motors with modern solid state drive systems which are now very efficient and well developed, and you have infinite control over the speed and direction of rotation of the propeller, so it's a very flexible plant.
The propellers themselves are being made in Poland at the ABB plant in Elblag. Molten bronze being poured into the molds is the first part of the process. Once the metal has cooled, the molds are removed and the job of planing down the surfaces begins. When Aurora's sister ship, Oriana, was launched a few years earlier, she developed vibration problems at high speed that were eventually traced to the propeller system. The problems resulted in the ship having to be taken out of service for a while whilst it was repaired. Everyone working on this ship is determined to take infinite pains to make sure that that experience isn't repeated with the new superliner.